This is a diagram of the humerus holding the forearm of a person. Let's look at the information here. So the force of gravity of the arm is 41.5 newtons, and the person's just holding their arm out straight. And this is the deltoid muscle. Our job in this question is to find out what tension force is existing in the deltoid muscle at an angle of 12 degrees here. And what's the force exerted on the shoulder going downwards this way. Let's take a look at our distances. Our distance for the attachment of the deltoid muscle is 0.080 meters from the point O here. And point O is going to serve as our point of rotation. And the distance of the weight of the arm from that point O is 0.290 meters. Okay, so let's go ahead and use this as our point of rotation. And then we're looking at the sum of all torques equaling 0 again. So we'll do the sum of the torques equals 0 about point O is going to be the force of gravity of this arm multiplied by the distance to the point of rotation. And that'll be negative torque since it is doing clockwise torque. So that's going to equal negative 41.5. Okay, multiplied by 0.290. Okay, and the deltoid muscle is doing the counterclockwise torque, which is positive, and that's at 12 degrees. So we're going to go plus the force tension, okay, multiplied by the distance of 0.080, multiplied by the sine of 12. Okay, and then we can find the force tension. Okay, and the force tension is 724 newtons. Okay, now our job is going to be to find the force of the shoulder. Remember, this will break into X and Y. I'll just put dots there for a little bit for clarity. So we're going to need to get force shoulder in the X, and we'll need to get force shoulder in the Y. Well, very similar to our question before with the crane, we're going to have force tension X and force shoulder X sum up to equal 0. So we're going to do the sum of all forces in the X direction. Okay, does equal 0. And that's going to equal force shoulder X, okay, minus force tension X, which would then be 724 cosine of 12. Okay, and the force shoulder X has a value of 708 newtons. Now we'll do the sum of the forces in the Y direction, also equals 0. That's going to equal force shoulder in the Y direction, plus our force tension in the X direction, which would then be 724 sine of 12. And then minus the 41.5, okay, which is the force of gravity going downwards. So again, we have force gravity downwards, force shoulder in the Y, and then force tension in the Y. Okay, and our force shoulder in the Y direction is actually going to come out as a negative value, negative 109 newtons. What that means is the shoulder is being pulled down. Okay. Now let's get the value for force shoulder. That's going to be equal to the Pythagoreization of those two values. So I'll take the 708 squared plus, and I'm going to put this in parentheses, negative 109 squared. We should do that always on your calculator when you have a negative value in your squared. And the force shoulder then has a value of 716 newtons. And again, we could find the angle of this by taking the inverse tangent of the force shoulder Y and then divided by the force shoulder X. But again, we're not going to do that for this question.